Everyone. So today we are going to solve snake and ladder problem. That is 17th of August gigs for gigs problem of the day. What this problem is saying is, do you guys maybe I'm expecting like in your childhood you have played that snakes and ladder sport, right? That is the same game that we have to basically not designing. Basically, we have to find out the minimum number of moves that we can move from source to destination. So what this problem is saying is we have given an input that is n. So this input is saying to you like there is a board of 6 cross 6, basically n cross n. But in our childhood that we have played is mostly 10 cross 10. So but here this is varying, and these are ladders and snackers map. So what is saying is, so ladders is like you can jump from particular this coordinate to this coordinate. So these are given in the pair values like 3 comma 22 one pair, 5 comma 8 is a one pair, this is one pair and this is one pair. How to read this? So you can tell this like so there is a ladder from 3 to 22. So basically if you came here 3, so you can jump to the 22. Similarly, if you came to 20, then you can jump to 32 directly. Like you cannot stay at 22. You have to jump into the corresponding cell that is 32. Same for snake case. This is one pair. This is one pair. These are numbers are given in the pairs, and you can see like this. From 17, you have to move to the 4. So snake will move to your to the corresponding cell. So from 19 to 7, like this. And we have to find out. So we are going to start this game from source that is 1, and we have to reach this destination that is n cross n number that is 36 in this example. So we have to find the minimum number of moves that we need to take to reach from this number 1 to 36. There can be a possibility that you cannot reach number 1 to 36. In that case, you have to return -1. And if you are reaching there, then you have to return the minimum number of moves. Okay. So for this example, if we are seeing what is the optimal path, that is the minimum number of moves that we are going to take is. So we are going to start this game from 1, and consider we have a dice also that can give you number from 1 to 6, and you have to choose like which is the number that you are going to take it. You can take any number from 1 to 6, and according to that number you have to move from source to that particular number, and from there you have to find out the number of minimum number of moves. So basically what he's trying to say is, let's start game from 1. So what is like if I'm throwing like 4, I can choose number 4, right? I can choose any number from 1 to 6, but for this optimal path I'm taking 4. If I'm taking 4, then I will move to 4 plus 1, that is 5, and I will take a ladder that is 5 to 8. I reached till 8. Okay. In the next move, I am throwing 3, then it means I am taking the number 11, 8 plus 3, that is 11. And now from this ladder, I will move to 35. And from 35 to, I will move to 36. This is the optimal path. Three moves we have took, 1 to 5, and 8 to 11, and 35 to 36. So there are total three moves. If you will try to other coordination also, you will not be going to be find out. Consider like if you will move 1 to 3, then from 3 to you move 22, and from 22 you move like 23, 24, 23, 24, 5, 6, 7, 8. All those numbers if you will try, you will not going to be get the 36 in the minimum number of moves. However, if you will going to through this path, you will bite by 30 snake on 34, and you will reach again 1, and you have to start it again from 1. So this is of course not going to be an optimal solution. So this is the example like that we need to take care. Okay, let's go to whiteboard to understand what it is saying is. Consider you are at 1. So what are the possible moves? As I'm explaining in every video, like you have to go to the brute force solution. What is the problem is saying? Try to replicate that scenario again. So what it is saying is you can take 1 to 6 multiple moves, and you need to decide the optimal path. Okay, we are going to blindly check. We are not thinking anything else. We are saying, okay, we will blindly check. What is the problem is saying is you have to take all the path from 1 to 6. Okay, if I'm at the source, initially I'm at 1. If I'm taking one path, like basically if I'm my dice is saying 1, then where I will reach? I will reach 2. Similarly for here 3, and here 4, here 5, this is 6, and this is 7. Okay. Can I go somewhere from 2, check the this snake and ladder. So this is 3, it's the starting point for this. This is 5 and this is 11. So I'm marking them so that to more readable. 34 and 21. Is 2 is there in the ladder or snake? No, it is not there. So you have to go further. 1 to 6 we are going. 3, can you go somewhere? No, 3 we cannot go. So again you have to go 1 to 6. 4, can we go somewhere? No, 4 we cannot also go somewhere. So again 1 to 6 we have to do. 5, can we go? Yeah, 5. From 5 we can go to 8. So immediately when you reach to 5, immediately you have to move to the 8. You cannot do. And this is not a move. This is just a property of the ladder or snake. So you have to immediately move to 8, and from there you can you can check like from 8, can we go somewhere? No. So then you have to try 1 to 6, all the path, possible path. Hope you will understand this. Similarly, for from 8, can we go somewhere? No. Similarly, you have to find 1 to 8, 6, all the path. And from 7, can we go somewhere? Uh, no, from 7 we cannot go somewhere, so you have to find all the 1 to 6 path. Similarly, this will branching to all those nodes, and you have to find out what is the minimal number of the path that you are going to take to reach the number 36. In our this optimal example, what we are going to do is from 1 to 5 we reach, and 5 to 8 we it's not a move, it's just a property of the ladder. Then you move 8, and from 8 you are reaching to 11, and from 11 you are reaching to 34. Similarly, you will then reach to the 36. Okay, so this is the example. From 11 you are reaching to, sorry, to 35, not 34. So this is the example that you can think of, like how you are going to write the brute force solution. Like what is the brute force solution that you can think of, and in this manner we are going to write the code. So okay, first thing is this logic you have to understood how we are going to take, and the second thing is how we check in the this ladder or snake this value is present. Like as I've tell you, like okay, from 5 we can go to 8. Okay, 5 you can go to 8. So how you will find out for every number in every use case, you have to iterate through ladder array and through snake array to find out the corresponding number. That is one of the solution. Like you can iterate over the ladder, and these are the going to be fixed size. Like if I'm checking the constraints, so ladder size and snake size array will be between to 1 to n square. And so it means they can be possible, like ladder size of the array is like 1 to n square. So every time if you are iterating over the ladder or snake array, this will increase your time complexity of the program. Okay. First time complexity will be to going from one cell to what are the possible cells that we are moving. That is the one time complexity code. Second one is to check like, okay, from this particular cell, can I corresponding, is there any corresponding cell that I can move there? So that is the other thing that you are going to iterate over that. So to reduce that part, at least like from where I can go to this part, what I can do is you can think of like it's a map, right? Because there is a corresponding pair from every time 3 you will move to 22. There is nothing else. So you can create a map, and you can just store the values of like 3 from where you can go to 3 to 22, and similarly from 5 to 8, 11 to 35, 20 to 32. Now some people are saying create different arrays, ladder or snakes, but that is not a feasible solution, right? You have to, what you have to do is if you reach any cell and that cell is present in the ladder or snake, you have to move to the corresponding cell. There is no choice in that. So what you can do is you can similarly put those snakes value into this same map also. Okay, like 17 comma 4. So it means if you reach 17, you have to move to the corresponding cell, that is 4. So similarly we can create this map to checking in the big of one time. It will give us the big of in the big of one time, and it will reduce directly our complexity from big of n squared this path to big of 1. Like we can directly check in the big of 1, like if map contains that particular 5, if it contains, then what is the corresponding value for that particular 5 that we have to reach there. And from where then we will again find out if map contains this value. If not, then we will just iterate 1 to 6 and we will check what is the optimal path. So this is one of the possible solution. Okay, like and let's see how we will write the code for this. So I'm going to write the code in the Java, like this is Java code. So if you're not comfortable with Java, you can try it around in your preferred approach. But the logic, you have to understood what we are trying to achieve here. Okay. So what is this is saying? I created one map and I'm like fill map. I created one function. But what it is doing is it just putting the ladder values into the map. Like similarly that I have shown you, like 322, 58. It creates those pairs and putting it on the map. And similarly for snake into the same map. I'm not using some different map. So in the same map, I am adding that. What is the -1 condition? -1, it means you are not reaching the destination. When you cannot reach the destination, like if consider like this is can be one of the solution. Like consider there is a snake at 36. Every time if you are reaching to 36 destination cell, there is a snake that will bite you and it will put you on somewhere on the board. So it means every time if you are reaching there, you are not going to reach at any time at 36, right? Because every time you are reaching 36, it will bite you and it will put you on somewhere else. So it means if that is the condition, like if map dot contain that destination number and map dot get of destination number is less than the destination that we are going to achieve, then it means that this is not a possible solution. Then we have to return the -1 upfront. And coming to this, I created one visited array. Why I created this, I will tell you in some time. So consider I have a function find minimum, but I'm passing here is that what are the values that we require is destination that we require, source, map that we require, and visited. Visited array, I will tell you why we require that. So coming to this part, these are the base conditions. Skip that part as of now, and we are just thinking that we logic that we have seen in the whiteboard. What is that is you are going to from 1 to 6. These are the dice numbers like dice 1, 2, 3, 4, 5, 6. For every path, for every possible path, like 1 to 1, 2, 3, 4, 5, 6. What I'm trying to achieve is initially my move is 0, right? Because I've not took any move till now here. And what I'm going to do is I'm going to take the move when I'm going to reach the cell, right? This is the, you can say like next cell basically. Next cell will be source plus I. Source is your current cell that is 1. And from where +1, if you take dice number as the 1, where you are reaching, that is 2. So this is your next cell that you are going to achieve. But we need to check one condition, right? If that reaching cell, next cell 2, is present in the map or not. If it is present, what it is saying it means there is a corresponding number of that present in either in ladder or snake, whatever it is, then we have to move that particular cell. So basically, if that particular number is present in the map, what I'm doing is I'm taking move and I'm incrementing one move, right? Because I've took one move from this dice and find minimum the same function. I'm doing recursion here, like destination, and I'm going to this particular path, map dot get of a cell, like it means corresponding cell, same map and visited. But if that number is not present in the map, it means that number is not like there is no snake or ladder came into that number. So for that numbers, I'm just taking at that simple data number and I'm going further from that number. Okay. And finally, I will figure it out what are the minimum number of moves that I have to, and I'm just returning the minimum. So this is the in the similar fashion, like I wrote this code that I've explained on the whiteboard. Okay, coming to this part of the visited array, consider there is a, you are starting your journey from 1. You reach like consider some cell that is a number. Consider from A there is a number B and there is a B, consider there is a snake and that will came to you at 8, A. So every time like consider you are going from 1 to A to B, and now from B you again went to A. From A, there is a like every time like 1 to 6 you are checking dice, and there is one use case will stay say like stay will be same. Like from A you will again go to B, B will move to A, and this cycle will go on further and further and further. So this will give you TLE, right? There is no point to going and into this loop. This is a cycle basically from A to B, B to A to B, B to A. So to skip that cycle, what I can do is I'm marking this A as visited and I'm checking at B. If my next cell is reaching at A that is already visited, I'm not going to take this. Okay, I'm not going to take this because there is no use case for taking this, right? Again, I'm going this and then I will reach from A to B. So there is no point of to going back to A. So I'm skipping this part and I will check the other possibilities that from B I can achieve. Okay, so for that to tracking, I'm creating this visited array and I am checking this visited array if this is source is already visited. So I'm just returning some maximum value so that I need to no need to take care from here. Otherwise, I'm marking this node as visited, like visited of A is true, so that next time if someone is achieving here, they will identify visited of one is true, visited of A is true, so that they can identify, okay, we don't need to reach there again. And if the I move all those numbers and there is like I found out to my solution whatever it is, then I'm backtracking this to visited of source as false, so that next time, like consider this is the example, like from C you are going to D. So consider from 1 to A to B, you are did all the iterations from A. Now you are marking A as false again, so that it will available for every other path. Okay. Consider there are multiple other paths, and from D to A you are going again. So from now you can move, right? Because there is no same path cycle exist, but now this time you can move to here. So to backtrack, I'm just marking this as false so that it will be available for every other nodes. And like this, I will going to, and I'm just checking like if answer my is greater than this value 189, then I'm just returning -1 because there will be no possible path. Otherwise, I'm returning the answer. How this fill map function works? So fill map is nothing but I'm just this is a map, and these values are given in pair. So I'm just incrementing my value by 2, so that from 0, first I'm taking 0 and 1 as a pair. Then I will 0 plus 2, that is 2 plus 3, 2 and 3, and 2 plus 2, 4, and 4 and 5 is pair. Like similarly, I can go till the end. So if you run this program, you will get TLE. Why? Because for every case, for every number, I'm doing like 6 possible combinations. So it is an exponential time complexity program, that is 6 raised to power n cross n. You would say where n is your input board number. So for every number, what I'm doing here is in the worst case, I'm doing the six like exponential. For every number, I'm finding like 6 possible paths from those number. I'm finding those again 6, and like this it will going on and on. So this will give you TLE. It will not be able to run for the sample test cases that we have given in the input. So this is a TLE. I showed you program so that's why you will understand how a beginner like brute force solution will work for you. Okay, how you will understand the program and write the approach for this. Okay, so where we are doing the problem here, this we optimized like field map this part, but where we are what we are doing here is we are finding every optimal path, like every path from here, and then we are finding the optimal path. Okay, in place of that, can I start from like this? In place of this, can I do like this, something like that, so that consider I have some this. So this is first of all DFS solution. If you are going with the terminology, so this is the DFS solution because we are going into depth from every node. In place of that, what I can do is, do I really require to go into each of depth? What I'm trying to say is, consider you have one, you are reaching from one to A, you are reaching from A to B, you are reaching from B to, like consider this is the destination. So first, what I'm doing here is 1 to A to B, B to D, and like I'm going to further and further and further. If I'm not finding solution, or if I found out the solution, I'm taking this as one of the solution. Then I'm backtracking from there. Consider another branching is starting. Then I'm going into the depth for this. And similarly for backtrack, then I'm doing, and similarly I'm going. Do I really require, in place of that, can I do something like that? I will initially store this one. I will store all the possible numbers that I can go from here, and I can then again store the all the possible numbers that from there I can go. And consider if you find out the destination cell here only, you don't need to do these paths, right? This is the minimum number that you find out because this is the minimum number of level that you can find out. Basically, you can consider it as a tree level type like there is a number there is a this node initially, and there are multiple like branching strategies are there, and in place of going into the depth, we are doing the breadth, like we are checking in the breadth, is there a node destination node that we find out first? It means that is the minimum number of moves that we it is giving to us, right? So what I'm trying to say here is, consider you have source one. Similar example, like we are going to take from one where I can go, from one where I can go to two, I can go to three, I can go to four, I can go to five, but five is present in the map, so I'm skipping this. I'm moving to eight, the corresponding cell. I can move to five, I can move to six, I can move to seven. So like this, you can move, you can check. Now from 2 where you can move, then I will write those. From 3 where you can move, from 4 where you can move. Similarly, from 8 where you can move to 12, 11. Okay, so from 8 you are moving to 11, and there is a 11, there is a ladder at 35. So similarly, we will find out, okay, we will reach at the 35, and from 35 you will reach to plus one number that you will reach at the 36. So you can find out the at the minimum time, right? There is no need to require to go into the third depth, fourth depth, sixth depth, seventh depth. They are not going to be useful. So this is the breadth first solution. This is the optimized kernel that we are. I am going to write for the as of the for the optimization approach. Okay, so I've already written the code in Java to save the time. Okay. Same example, consider like fill map that we are doing because we need to check in the big O one, like from where we can go to that corresponding cell. And similarly, like minimum number of moves I'm taking at 0 and destination we have n cross n, and I'm taking as a queue to for the BFS approach. And I'm creating again visited array. Why? Because again you can have that possibility, like you can go to 1 to A to B, and B will some there is a snake at B that you will can again reach to A, and then you are starting your journey again from A. There is no point in that, right? So to skipping those part, I'm taking as a visited array, and I'm initially adding one into my queue and null. Why I'm taking as a null? So to increment number of the moves, like if I'm encountered at null, it means one breath I've done completely. It means one path, one breath, like from here, this one level I did completely, and I'm incrementing the minimum number of moves from here. Okay. If I'm doing the second path again, then it means I'm incrementing again one complete path, but I'm not able to find the destination. So you can like think like this. But there is a way, if you don't want to add like null into your program, then it's also fine. You can just add one, and you can check like when we are adding here, you can because this is one iteration of the path, then you can increment your counter here, and you will go further. So this is the case. If source I am finding out null, it means I'm doing all the iteration from one, and I figured it out null. So what I can do, I will again add null. I will increment my level, that is minimum number of moves. I will increment and just continue. If my source, if I find out destination, it means the minimum number of moves, right? Because it means we are going in the breadth first, right? So if I figured it out destination at the earliest, it means this is the minimum number of moves that I came till I using this I am reaching here. Before this I'm not reaching the destination. So if that is the case, otherwise if source is then I'm just continuing. Otherwise I'm marking source as true, and again I'm moving from all the dice 1 to 6. Again, like this is an Excel same program. Like if I'm checking if it is there, then it means I have to take that value. If it is not there, then I'm taking the original value, that is source plus dice. If the next cell I'm going to there, it is greater than destination, there is no point to continue, right? So I'm continuing the code from here, or otherwise I will add into my queue. And if I'm find out the solution in between of those paths, then I'm returning the minimum moves. If I'm not able to find out, then I'm just returning the -1. And fill map is the same code that we have explained, we have seen for earlier. So you can I hope you will understand. I'm trying my best to explain this, but still, if you have doubt, you can comment on video. And if you like or learn something new, please like and subscribe my channel.